Good afternoon. All right. Python programs on Windows systems. What's the best way to do that? And how can you get the most out of all of the existing Python programs that are out there and use them in your day-to-day operations with information security? Okay, so with that, I have no slides for this presentation. I'm going to be running this entire presentation as a live demo. So we're going to start out with a Windows system. We're going to go through the installation and talk about how to install various Python projects and how to make them run properly on our Windows systems. So with that, let's jump over to some demonstration. All right, so here, starting out with a VM, right? This virtual machine, well, actually this virtual machine, I just downloaded this. Let me come back over here to my slides, my browser. Actually, let's open up a browser. Sorry, I'll come back over here and open up a browser. And I'm just going to go to Google. Just if you wanted to start out with a plain Windows system, if you didn't want to install Python on your computer systems and you want to experiment, I'm going to just go to Google and search for Microsoft download developer VM. And this is going to take me out here to a website here. You can see developer.microsoft.com. US virtual machine. Here you can see that I can come out here and I can download a virtual machine either in VMware, Hyper-V, VirtualBox, or Parallels. This will give me a Windows computer that is licensed for, well, until this, in this case, until September 11th, 2022, that I can begin to experiment with. It comes pre-installed with some application development tools and things like that. All right, so this is a 20 gigabyte download. This would take a while. I've already downloaded that file and installed it here in VMware. I've also downloaded a couple of other things that will take a little bit of time to download to make this demo go a little bit faster. All right, so here I've got my brand new Windows system. I want to install Python on it. Where do I get that? Well, I'm going to come out here. Well, actually, let me show you a couple of things before I show you where we can download it. First of all, in a brand new Windows system, if your Windows system is using a Microsoft login, and like you have access to the Microsoft App Store, if you just type Python on any Windows system, it's going to launch Microsoft's App Store, and it's going to take you out here and ask you if you'd like to download and install Python on your system. So this version of Python that you install here, if I click Get, it's going to install Python on my system. This is really interesting to me because it gives us a strong indication of how important Python is to Microsoft, right? If you try that for just about any other application, you'll find that it's not there. As a matter of fact, this is actually controlled by the application aliases. So if we go to, let's see, execution aliases, and when I look at the execution aliases that I have on my computer here I can see execution aliases. You can think of as built-in shortcuts for the command prompt, right? You run a command and it redirects you to some other command. For example, to run Microsoft Paint, I can type MS Paint, I can type PBrush, and each of these will take me to Microsoft Paint. Well, with the application aliases that come with Microsoft, you can see that Python.exe and Python 3, both of those commands are aliased to the app installer, which means if you type them, it's going to take you to the Microsoft App Store and suggest you install those. And if you look through all of the other aliases that are here, right, there's not really any of them. The ones that I've seen that will do this, the other tools that it'll redirect you to the App Store for, I know Spotify does that if you don't have it installed. But really, that's it, right? There's not very many applications that Microsoft has said these are important enough that if you run the command and it's not installed, instead of giving you a file not found message, we're going to redirect you to the App Store. So that's interesting to me. Now, of course, if you have a Linux virtual machine installed on your system already, so you've got a Windows, not a virtual machine, but a Linux subsystem on your Windows computer, then you actually have Python installed, and you can run Python programs from within the Linux subsystem rather than installing Python on Windows. So those are some options for you, but I really prefer to download Python from python.org. One thing is, I'll say this, so python.org. If I were to come out here and use the application alias, so in here I typed Python and then I installed Python from the Microsoft App Store. If I was to install this Python here, this would not make Python, actually in my virtual machine, I've already got Python installed there, but over here, where I typed Python and it took me back to the Microsoft App Store. If I was to click Get here and to download Python from Microsoft's App Store, this is not going to install it where anybody can run it on my computer. It's only going to put it in my user profile. So it's not going to put it under program files. It's installing things under my user profile's local apps. So that's one reason I find it less desirable. The other reason is using and managing virtual environments using this version of Python is not that straightforward. It's not a simple task. Whereas it is very simple when we use the actual Python installer. Now, both this Python and the Python that we get from python.org are the same Python. It's just this version on Microsoft's App Store is just a repackaged version of Python that we would get from python.org. Okay, now there's lots of different Python interpreters out there. There's, I'm sure you've probably heard of things like IPython, Jupyter Labs or Jupyter Notebooks would be another example of Python interpreters. There's Python interpreters that'll run in your browser like Jython. There's a Python interpreter called IronPython, which is specifically designed to run on Windows systems using the .NET platform. And all of these different interpreters are out there, but python.org distributes what we call the CPython, which is the main Python interpreter. And out here I can come to downloads, and here I can download the latest version of Python for Windows. If I want an older version or a different version, then I can follow these links to do that. But here, if I just click this, that's going to download Python to my computer. In this case, I'm downloading Python 3.10 to my computer. All right, so I've already downloaded that and got that here in this virtual machine. If I then double click on it and it starts to run, you're going to get a bunch of different installations. Okay, so I'm going to modify my existing installation just to show you what the options are as we go through here. So these first couple of options, documentation, pip, TCL, and the Python test suites, I will generally always install these. And the other thing you really want is you want the Python launcher, and you want it to be installed for all users. Okay, so you want the Python launcher, and you want that for all users. There are some options here where right now I've got this set to select install for all users. The default here is that this is not selected, and it's going to ask, and it's going to try and install that program into your user profile. So I'll say install for all users, and then you can select these associations if you'd like, and you can these other associations. The rest of these things I usually do not select, as well as add Python environment to path. Now, it's very common for Windows administrators to install and add Python to the environment variables and add Python to your path. That's really unnecessary, as we'll talk about here in a little bit. These other ones at the bottom. Now, the question as to whether or not you want to install the debugger symbols and the debugger binaries really come down to how you're going to be using this Python installation. Are you using this Python installation for development purposes? In other words, are you writing Python programs, or are you just trying to run Python programs? And if you're just trying to run Python programs, then you don't need to select these. Really, the only change I would make here is install for all users. And then we click install, and it goes through the installation process. Once it's done with that installation process, I'm going to cancel this so I don't have to watch this again. Then you'll have some Python stuff that's been added to your start box, or start menu. You can see I got idle here. I've got Python 3.10. I've got some other links to manuals and things like that are available when I type Python there. But primarily when we run Python programs on Windows systems, we're going to be running them from the command prompt. So if you were to download a Python program, here I've got a little Python program called Hello World that's just going to print some things to the screen. If after installing Python, if I was to just click on these Python programs on Windows, well, in this case, I got something happen and then it generated an exit code. Let me right click and let's try and run this program. Open with Python 3.10. You see what it's doing is it is opening that program and it's running it, and then it's just exiting, right? So very typically, Python programs are written such that they're anticipated to be run from the command line. That's not true of all Python programs. You do have Python programs out there that will run and pop up graphical user interfaces, but very typically, Python programs are designed to be run from a command line. So here at my desktop, if I look, there's my Hello World program. Let's just cat Hello World, or let's just type. Sorry, I will try not to do Unix commands or Linux commands here. Here I can see that I've got this thing. It's going to print hello from Python, and then it's going to print a bunch of characters to the screen. These other things with pound signs in front of them are just comments. So to run this, if you were on a Linux system, you would expect that you would type Python hello world.py. And in this case, Python does actually find that program and run it. Python is working in this particular instance, but this is not really the way that you want to run programs on Python using or on Windows systems using the Python command. Instead, what we want to use is the py command. Py is actually the window or the launcher for Python on Windows, and its job is to find out what version or where your Python installation is, and then to run that. And I'll show you what I mean by that in just a little bit. So it's not actually the Python command that you want to use on Windows to run programs. You don't want to use Python. You want to use py to launch your programs. Now, a couple things I'll point out here is one is you'll notice that this Python program, it printed hello Python, and then it started printing a bunch of emojis to the screen. Now, this looks great if I'm running this thing in a terminal, right? So here I'm using the Windows terminal. The Windows terminal has a PowerShell prompt that's giving me access to, it's running in the terminal. If I was to just run a plain old command prompt, so if you're on an older version of Windows where you don't have Microsoft Terminal installed, or you're just running, so just running a command prompt. For example, it's CMD, and then I'm going to come over here and run CMD as an administrator. All right, so this is not running in Windows Terminal. This is just running as a command prompt. So with a plain old command prompt, cd into /users /user /desktop. Let's color F0 so it's a little easier to see. And then we're going to say Python hello world. So here you can see that at the command prompt, many of these icons and things like that don't render, right? It's technically has to do with the support for UTF-8 characters, which is the default for Python and really the default for the world moving forward. Most of our web pages are transmitting UTF-8 back and forth. The days of ASCII characters are behind us for the most part, and Windows is moving in that direction where they support those additional characters in their terminal programs. But in order for that to happen, it has to be running inside of Microsoft Terminal. Now, this is true whether you're in PowerShell or even here in a terminal prompt, a command prompt in a terminal prompt, Python hello world. You can see that it works nicely here in a command prompt as well. So it's the terminal that's doing this. The difference is the old Microsoft Windows console platform didn't support those things, but this terminal does, whether you're in PowerShell or command prompts. So that's very nice that we can run these programs and have that support. But you'll want to have terminal if you have these broken characters that are appearing inside of your Python programs. Well, then it's probably because you're not running them inside of Windows Terminal. All right. So I said you want to use the Python launcher in order to really run your programs instead of using python.exe. Well, why is that? And what is the Python launcher? Well, the Python launcher, py.exe, let me come back over here to my PowerShell prompt. Let's do Control L. The PowerShell prompt, py, what its job is to find the Python interpreter, even when you're not inside of, or even when python.exe is not in the Windows path, right? You haven't added Python to path, py will still find the exe, or find the Python interpreter, and then launch it. It has several options, like if you have Python 2 and Python 3 installed, I could do -2 to run Python 2. I don't have Python 2 installed, but if I have -3 installed, and it actually gives me a little suggestion. So it says you do have Python 3 installed. So you can use this to launch various versions of Python that you got installed, and this would force it to run Python 3. So it's got options like that. The other thing that really makes py.exe powerful is its interactions with virtual environments and the fact that we have virtual environments that we can support on Windows. So once I've got py installed, I can then start or Python installed, I can then start installing packages. And this is where we're going to need to talk about virtual environments and how to install things on our Windows systems, and so I can run these awesome Python programs that are available to me on the internet. A program that you get with Python to install packages is called pip. Right? Pip is the Python's package manager, if you will. And its job is to reach out to Python's app store, where they've got all of these awesome Python applications, download those and install them into your Python environments. Now, I really do not want to install anything into my main Python installation. That installation I have under C:\program files where Python got installed. I don't want to install additional packages and things like that into those environments because, well, you can run into version conflicts. If I have an application that requires SCAPI 1 and a different application that requires SCAPI 2, if I'm installing packages into my Python installation, then, well, I can only have one of those. And it could I'll run into conflicts and things like that. And your environment can quickly degrade. As a matter of fact, there's a great XKCD cartoon out there that illustrates this point. XKCD Python environment. Okay, so this particular XKCD is showing you all of the different ways that modules and libraries can be installed and managed on systems and all of the different directories that they go to. And really, they're just trying to illustrate that this thing is confusing. Where things get put can be problematic. Problems get things break. I find that it's not uncommon for people to do things like download a Linux distribution off the internet that has all of these great tools, security tools pre-installed for them, and they'll use it for a while, and then they'll pause their VM, come back 6 months later, go to unpause the VM, then they'll install all of these patches from the internet, right? Go and install all the updates to the platform, and then all their Python programs that they had installed and working are now broken. That's because on Linux systems, there is a separate Python installation that comes with the operating system, and the operating system depends upon that. So the operating system, when you install patches, it upgrades the Python that's installed for its use, which causes those version conflicts that we were talking about. And so the Python applications break. So I want to avoid all of this mess you see here on the screen. I really don't want to install things in Python's environment. So instead, what I'll do is I will use a virtual environment. Now, the way that we use virtual environments in Python is we're going to use pi to run a program, pi minus m venv. Okay, so venv is the name of the program that we use to create virtual environments. The virtual environment, when you hear virtual environment, I tend to think things like, well, VMware or containers or some kind of hypervisor type technology. That's not what virtual environments are in Python. In Python, they're just a directory that stores modules. Okay, so let's create a Python virtual environment. Now, when I typically do this, I will put things into my home directory in a directory called pyenv. Now, I'll point out in a PowerShell, you can typically use a tilde and to point to your home folder. If you're going to do that, you do have to hit the tab key and let it resolve that, venv, tilde, and then hit my tab key, let it figure that out. Oh, it's not figuring that out. There we go. Tilde slash, and then tab, let it figure that out. Because if you just put the tilde there, it'll actually create a directory named tilde. So venv is what's reading this, and if it sees a tilde there, it creates a tilde directory. Let me show you what I mean by that real quick. All right, tilde slash test. All right, what this is going to do is this is going to, on my desktop, create a folder called tilde, and that's not what I want. All right, so when you're creating virtual environments in Windows, let me kill that. You're going to hit tilde slash, hit tab so that it will change that to C:\users, and then point it to wherever you want to create your virtual environments. Now, I typically keep all of my virtual environments in the same folder. I create a little folder called Python envs that I keep those things in. And then I'm going to call this one my new env. Okay, so what this is doing is this is creating under Python environments, my new env, a new folder. It's just setting up the package structure that is required for managing Python packages. And it's going to also drop a copy of the Python interpreter in there. All right. Now, if I was to type Python here, it runs Python. Now, which copy of Python am I running? The way that you figure out where that Python command is coming from in PowerShell is you use the get command, Python. And then you ask for that command's source, and that'll tell you the location of where that's coming from. All right, so you can see here that I'm running Python actually out of my user's home folder is where it is. So when I type Python, I must have actually installed Python on my user's home folder. So I'm not even running the Python that is in my home or under C:\python.exe. That's interesting. All right, so that's not the Python I want. So the question becomes, where are the modules associated with this particular program? Every copy of python.exe gets its own unique set of modules. So if I was to install something using this copy of Python, if I was to say python -m pip, right, that would install things into wherever the libraries are for this copy of Python. Well, what I want to do is I want to make sure that I install Python environments or all my Python packages into this virtual environment. Now let's just take a look at this folder that it created here. Let's go to, open this up. Let's go to C:\users user. Here's my Python environments. And there's my new env. Now, if I look in there, I can see that it created a couple of directories. There's an include directory. There's a lib directory. There's a scripts directory. So inside the scripts directory here on Windows is where it puts, well, a copy of Python's interpreter. Now, my path, my operating system path, isn't going to find this copy of this Python interpreter. Instead, it's going to find, well, the one that's been installed in my environment. So how can I make it use that copy of the Python interpreter? Well, I could, let's do this. I could say Python, or I could specify that full path. I could say users, user, Python environments, scripts, Python envs, my new env scripts, Python, okay? So in this case, I am specifically running that Python interpreter, and this Python interpreter will find its modules and install it there. Let me go ahead and install a package here and show you what I mean. Let's see, exit. Let's go ahead and install a Python package. So I'm going to say or actually let's just use pip. Let's say pip install, and then I'm going to install a package like Scapy. I'll install Scapy. Scapy is a tool that we use for packet manipulation, very commonly used in information security. This is going to reach out to the internet. It's going to find the Scapy package in basically what's the equivalent of Python's app store, and it's going to download it and install it in my environment. Okay, now the question is going to become, where is it going to install it? So while that's installing, let me give you a little bit more information about pip. Where did I get this name Scapy, and how can I figure out what the names of all of the packages that I can install are? The Microsoft, or the package store, if you will, where all of these packages are stored for Python, is on pypi.org. So if I come out here to pypi.org, I can search for things like Scapy, and it'll give me a list of modules. Or, it's got a thing where you can browse around and look at the different types of packages and things that are there. So here I can see that there's a package called Scapy. And when I click on that, I can get some information about the package module. And up here, it'll give me the installation command in order to install that package. So this is basically, I'm calling it like the App Store, but it's more like a Docker hub. You know how Docker hub is a central place where people register their Docker containers, but they actually exist in GitHub. The same is true here. Like, so if I come down here to Scapy and I click source code, this is going to redirect me over to the GitHub page where the Scapy project is actually stored. Now, Scapy is one type of project that I can install with pip. And there's various, not all Python projects are created equal. I would say Scapy is a package that's registered. It has a setup.py. If you see a setup.py, that's a strong indicator that the packages has a more sophisticated installation process. But setup.py is a key that we'll spend a little bit more time looking at in a second. All right, so I can install things with Scapy. Now, where did that thing get installed? Let's come over here. Let's just type Scapy. It says package not found. The term Scapy is not understood. What if I type pi minus m Scapy? It says has no version Scapy. So I've installed Scapy, but for whatever reason, I can't find Scapy and install it. So where did it actually install this version of Scapy? And the answer is, well, I don't even really know by just installing this. I mean, I know I installed Scapy. Right? Oh, by the way, if you are installing things from the package repository and you see these orange warnings or even red errors, that doesn't necessarily mean that the package didn't install. when Python tries to install things, it will search for installations based upon Python source code. It'll search for zipped up versions of those. It'll search for C versions that it has to compile. And if it just doesn't find one of those, it'll generate error messages and move on. As long as you see successfully installed whatever package you were installing at the bottom, then it probably installed your package just fine. So these warnings and even error messages that come up during the installation are normal. It's just as a result of it trying multiple ways. So this did successfully install Scapy, but I can't see Scapy working for me. Why is that? Well, I just don't know where it got installed, right? I could figure that out by looking around. And this is why we want to use virtual environments. Okay, so let's talk a little bit more about this virtual environment that I've created. I created a virtual environment, which I've called my VNV, and inside of the scripts folder, it put in there a little file that will activate that virtual environment. So let's activate this virtual environment. So let's say I'm going to pass the path to my home directory. And then I'm going to say Python environments and my new virtual environment, and then scripts, and then activate.ps. I could use a batch file, set the command prompt. I'm in PowerShell, so I'll use a PS1. Now, when I activate this virtual virtual environment, what it's really doing is it's changing my operating system's path so that when I type Python, it's no longer going to find the Python that was installed in my home directory or the one that's installed in the operating system. As a matter of fact, let's do that get command that we did earlier and look at where this is coming from. So get command dot source. Now I can see that the Python interpreter it's finding is the one that's inside of my virtual environment, right? So I'm controlling which Python interpreter I want by activating the virtual environment that's here. Okay. Now, so now if I do a pip install of Scapy, it's going to install Scapy into this virtual environment, this Python virtual environment. We'll take a little closer look at what that's doing here using Explorer. So up here under my virtual environments, there's a lib folder, and underneath lib, there's a site packages. And in here, I can see that, oh, look, there's new things being added. And I see that that Scapy folder was just added here. So this, my virtual environment is like a container that contains everything that's required in order to run all of the Python packages that are installed, well, in that virtual environment, including Scapy. So over here, now Scapy is installed. If I type Scapy, right, now it drops me into Scapy. So you want to use virtual environments in Scapy. What's more, let's look at this. Get command Scapy. Where is that coming from? I can see that even Scapy.exe was dropped inside of my new virtual environment. So this folder contains everything that's required for running Scapy. If I decide, you know what, I really don't want to have Scapy installed on my machine, then all I have to do is come out here and select the entire virtual environment, delete that directory, and it goes away. And then I'm back to exactly my pristine Python environment, except for the fact that, well, I did do a Scapy install, and I don't know where that went, right? So I would have to try and remove that Scapy, find that and remove that. So having a virtual environment allows you to keep all of your programs separate in different folders, each with their own unique installation and Python environment, where you're not going to have conflicts and things like that. Okay. So I would suggest always using virtual environments. Now, let's talk about installing and using some common programs that we use in information security. Programs like Scapy or Volatility, these are programs that I can just simply pip install Volatility 3. This, again, reaches out to pypy.org, goes to pypy.org's registry and says, all right, where is Volatility? And it redirects it to Volatility's GitHub page, and it downloads it from Volatility's GitHub page. Then it's going to install it and all of the requirements for that package inside of my, well, virtual environment. Now, in this case, I am just installing this in my new VENV environment. Very typically, I would keep a different virtual environment for each of the different programs that I install. So if I have a Scapy, I would have a virtual environment for Scapy. If I have I'm going to run volatility, I would have a different virtual environment for volatility. And again, the way that we activate these is we just run the activate script. Now, if I want to deactivate a script, or if I'm in a virtual environment, I want to switch to another one, then I can just type deactivate. That drops me out of that virtual environment. And then I could activate it again by running activate a different virtual environment by running the activate script that's inside of it. All right, so I've got these two programs, Python and volatility. If I try and run vol, right, it finds volatility and runs it. So get command vol dot source. Where's that coming from? Again, this is installed inside of my virtual environment. So Scapy and volatility, those types of packages, those are easy, but quite often we'll come across other types of projects that we have out on the internet that we want to install. For example, I have on my GitHub, I've got a package called APIify, right? And what APIify does is it lets you run a web server on a system, and then you can take any command line program and then have it execute, capture its output, and then provide it in a JSON response. So let's say you had some type of an enterprise monitoring system, and you wanted to be able to do NS lookups of IP addresses and have that resolve and be a field inside of your security event monitoring system. Then I could stand up APIify, and I could send things off and just basically capture who is output, or NS lookup or trace route or ping or whatever command you want as a JSON response, and include that in there. So if I look at APIify, how do I go about installing it? Well, usually there's a README on these things, and my this page does as well. But if I look at this program, I don't see a setup.py anywhere inside of this folder. Since there's no setup.py, I probably cannot just install this using pip. I'm going to have to download this program and then just run the scripts individually. Okay, so if there's no setup.py in the GitHub page, you can't install it with pip. There's other packages out there that aren't in that are not in PyPy, which means I can't just pip install them, but I can still install them with pip because they have setup.py. So there's one called let's see, the fake Apache log generator. Fake Apache log generator, as you might suspect, it generates fake Apache logs. So if you needed to test your enterprise managing system by generating a bunch of logs and feeding it in there and making sure your parsers were working correctly, I could download this particular application and get this thing to install. This is another one. It doesn't have a setup.py in it. Okay, so this is one that in order to install it, I would have to download this to my system and then install. Let me. I think I got another one that I do have on my GitHub page that does have a setup. So markbaggett.com/reassembler. If I look at the reassembler module here, this one does have a setup.py, which means that even if it's not published in pip, right? It's not, or pypy.org, so that I can just say pip install the name. I can still install this directly from the GitHub page. So I can grab this URL that contains the setup.py, and then over here in my Windows box or on a box, I can, as long as I've got git installed, what I could say is pip install, and then I can say git plus, and then give it the URL. And what this will do is this will reach out to that GitHub webpage. It'll see that, oh, there's a setup.py. It'll download that package to my system and then install it directly from the GitHub repository. This is also useful if you've done a pip install, right? So there's versions that people will package and publish through pypy.org so you can download and install them. And oftentimes they'll have newer versions that are on their GitHub page. So for example, if I'm interested in the new features that might be in Scapy version, the next version of Scapy, and those are on their GitHub page, but there's not a pip package, then I can use this syntax of pip install git plus, and then point it at that repository, and it'll allow me to install that directly from their repository. Okay, so those are two installations. Let's take a look at one, the third type of installation, type where there is no setup.py that's in the folder. For this, how do I install this? All right, let's just grab a copy of this. And, I could from GitHub, I could come here and let's see, download a zip file and make a copy of this, download that .py program. But also if you have Git, I can just check it out. So what I'm going to do here is I'm going to make a copy of that GitHub repository. I'm going to say git clone and then paste in that URL. And so this is going to download a copy of this GitHub repository. And I've picked this particular package repository because you're going to find that the installation here doesn't work. And I want to show you how we can repair this installation. All right. So now I'm going to CD into my fake package log generator. And if I do an ls, there's my package. If I just try and run it, Python Apache fake log generator, or instead of Python, let's use Pi. Okay, why Pi? Well, that's going to use the one that's inside of my virtual environment here. And I'll give you a little more details on that in a second. I can see that it's importing a module that doesn't exist, right? So I try to run it, it says no module name PyPTZ. It's very common in these Python package repositories that you have a requirements file. And if we take a look at the requirements file, what it's going to have in it is a list of different Python packages that also have to be installed in order for this package to run. Now, I don't want to one at a time install each of these different packages. So what I can do instead is I can say Python, I can say pip install -r. -r says, I'm going to give you a requirements file. And then we give it the requirements file. And what that does is it's going to read the contents of this requirements file. And then it's going to say, oh, I need to install Fake Factory and NumPy and Faker and PyTZ and TZ local. And it's going to begin installing these packages. Okay, so it's going to reach out and install these things. And what you're going to find is it's going to generate some errors here, that it's not going to be able to find these packages and install them. The reason why it's not is because, well, when the developer wrote this application, this was the latest versions of, I'm going to guess that this was the latest versions of these, or at least they were the versions that that he was targeting using, he or she was targeting using when they were building this application out. And then when they were done, they said, okay, let me just take the versions that I was using and put that as the requirements. And well, sometimes those versions are no longer available. Sometimes those versions are outdated. And so here it's doing this installation, but one of these are going to fail, or I can't remember if this one, if you install it, one of them fails during the install. That's one possibility. The other thing is that it might succeed in installing all of these different packages, but I may find that these packages are no longer compatible, right? That they don't interact in ways, or the functions that one depends on have been changed such that they just don't work anymore. So what you may try, and this is what I'm going to end up having to do in order to get this thing to work, is I'm not going to wait this thing out. Trust me that if I let this install, it would not work, right? It would break. So what I would do is I would say, all right, let's just open up that requirements file. Oops, not README. Go away, README. Let's open up the requirements file. And I would change these from equals to greater than or equals, right? So that it'll download the latest versions. Now, this doesn't always work, right? Because sometimes, well, the latest version is not compatible with things either. But and you might try these one at a time, right, to get the latest version of modules that are out there and figure out what's out. One thing that you can do when you have modules installed and you want to figure out if there's a newer version, you can say pip list. This shows you the packages that you've got installed in your virtual environment. You can say pip list -- outdated. And what this will do is it will tell you which versions of modules that you've got installed in your system, that there are newer versions of packages that are out there that are available for installation. So it's going to resolve those conflicts. So here I can see, all right, I've got pip 2204 and pip 22.1 is installed. If I want to upgrade that, I can just say pip install -- upgrade pip, and this is going to download the new pip install -- if I spelled upgrade correctly, that would install the new pip on my system. Okay. So you can see that even when I pip installed Scapy, it looks like I got an older version of Scapy, that there's a new version available. Okay. All right. So we can manage those packages. What I'm going to do here is I'm going to change all of these to greater than or equals to, save it. And then if I was to run that installation here, then that would work just fine. Okay. So with that, I want to show you just a couple more things. Just trust me that will work. I'm not going to have time to go through that whole thing. Let me show you a couple more things here with this. Let me close this out. Very typically, I said Python programs, if you just run them, right? If I just try and run them directly from the command prompt, then you're going to see that, well, it just pops up a window and closes. Let me, because what happens is that thing is expecting it to run as from a command line. Now, just so that we can see what's happening here, I'm going to come in here. I'm going to add one thing to the end of this program. I'm going to add this command input, right? That I can put anything I want in here, press any key or any key. Okay, and if I save that, now if I run it again, you'll see that, in fact, that runs, and now it's got that press any key. It's waiting for me to press enter. So it is actually running the programs when you double click on them in Python. It's just, well, it runs it and then it closes the program down, so you're not, you don't get to see those results. So to solve this, we can just run them from the command prompt. All right, well, now let's say that my program here, I want it to run inside my virtual environment. Where is this currently running from? Well, let's modify this. Let's open up this program. And let's have this program use Scapy. Okay, so I'm just going to unimport, or I'm going to uncomment this line here. So now this program is going to use Scapy, the Scapy module. And as you saw when I was out here at the terminal prompt, if I just type Scapy, it says, well, I Scapy. If I just come here, I type Scapy, there is no Scapy. So here, let's open this with Python. Oh, it's finding the Scapy that I pip installed here. So let's come back out here, pip uninstall Scapy. I'm not in my virtual environment here, right? I am not in the virtual environment. So let's do pip list. Okay. And you can see that this, let's say get command pip. Let's just see which pip I'm using. All right, I'm running the one that's in my this virtual environment. I'm going to uninstall Python Scapy from there. So I'm going to say, or actually, let's do this. Let's change it to something that I didn't install. Let's say import vol, the volatility program. Okay, so actually, no, I'm not sure that that's the correct import. Let's undo that. I'm going to say from Scapy.all, I'm going to unimport this, or I'm going to uninstall Scapy. I'm going to say pip uninstall Scapy. All right, so now if I'm on my desktop and I try and run this hello.py using Python, it doesn't find it. Scapy's not there. If I use this top one on the open with, this is actually the Python launcher. If I try that one, it still does not find it. Okay, so the problem is that Scapy is installed in my virtual environment, my Python virtual environment, but it's not inside the main Python environment. So if I activate this, if I say Python environments, my test, and then scripts activate. If it's activated, then Scapy exists. But if it's not activated, then Scapy doesn't exist. So the question becomes, if I have an icon on my desktop, how do I have that activate the virtual environment and then run the script first? Well, the answer is in this other line that I've got commented out here. I can, on Windows systems, add a shebang or pound sign exclamation point that then points to, let's see, what was the name of my virtual environment? I've forgotten. That points to my virtual environment. And my virtual environment here was tilde Python envs my new env. So I can add this line to the top of my Python scripts, my new env, that points to where the virtual environment is, points to the Python interpreter that's in this virtual environment. This is a shebang line. It works just like the shebang line does in Linux. Now, if I save that and I try and run it, if I run it with standard Python, right, so now if I click that and I run it with this second one, with the python.exe program, which is what that second one is, then same thing. It can't find Python. But if I run this with the Python launcher, which is that first one, then it does find it. So just to show you the difference there, let's try that again at the command prompt. So here, cd desktop. Here again, if I type Python and then my program, it says, nope, I can't find Scapy. Scapy doesn't exist because Scapy is not in my default Python installation. But if I use the Python launcher to install, to run this, then because this shebang line at the top of my hello world points to which Python virtual environment this Python program is supposed to run in, it now finds the module that's installed and executes it properly. Okay, so just to summarize what we've talked about throughout the day, you can type Python on any Windows system, and it will take you to the Microsoft App Store and tell you to install Python directly from there. I would suggest that is not the right way to do it. Instead, what you want to do is you want to go to python.org, and you want to download and install the latest version of Python from there. When you install it, you want to install it with install for all users, and you want to install the Python launcher. Use the Python launcher py.exe in running your programs. What's more, each package that you need to install on your Windows computer, before you install those, the first thing you should do is create a virtual environment using the command, press any key to continue, using the command python or py -m venv, and then pass it the path to a virtual environment, such as Python or Python environments, test2 or test2. This creates a new virtual environment. After this virtual environment, which is basically just like a brand new Python installation that is separate from everything else, has been created, then I can activate it by using the activation script that's in there. So Python environments, test2 under scripts, there is an activate.ps1. Once I activate that, it'll change my prompt. From this point forward, anything I install into this thing is going to reach out to the Python package store. Oops, there's nothing called reassembler with an L on the end. There's one called reassembler. That'll install that, but everything is kept separate, and I don't have to worry about conflicts and things like that. When I want to, then if I then run those commands, they can be run from within the Python virtual environment once it's been activated. Inside of an active virtual environment, it does drop executables into that virtual environment as well when you Python install, so that they are kept separate as well. If you've tried to create a virtual environment and you find you did it incorrectly, or there's something wrong with that virtual environment, you've got conflicts, you haven't messed up your main Python installation. Your main Python installation has been untouched. You haven't dropped libraries and things like that into that Python installation. All you have to do to get rid of a virtual environment is just select the directory, click delete, and click delete. And that virtual environment and all of the folders that were in there are gone. Okay, so that's it. That's the best way to manage these Python virtual environments on a Windows system. So I hope that was useful to you. That's really downloading, installing, and running Python programs on Windows computers. If you'd like some more details about that, or talk about how we can use these things in Linux environments as well, then check out 573. If you already know some Python coding, come check out SEC573, the advanced coding. But that's an advanced course. It's going to assume you know Python when you arrive. Okay. All right. That's what I have. If there's not anything else from the SANS team, I think that's it. Thanks for coming out. You can follow me on Twitter at Mark Baggett. I'm sure that's been scrolling across, or there it is on my display name there as well. Okay. Thanks for your time, and have a nice day.